Hello, everyone. Welcome to episode 9 of the Current Review podcast. This is take, I don't even know what take this is, but we've been trying. So today I have on the CEO and co-founder, John Gerwages of Ganaio, which is a company that is working on building suspension that can actually recuperate energy as it compresses, which I think is really cool. And we also have the other co-founder, Shashank, Reddy, Goli, on here to discuss this technology. I think this is really cool. And correct me if I'm wrong, but you both have graduated with mechanical engineering degrees.
That's correct. I,
That's
I have a
correct.
bachelor's. So does Shashank, but Shashank went a step further and got his master's in industrial engineering.
Ooh,
Yeah,
cool. So that's really exciting. And you've both also worked at Tesla in the past, correct?
That's
that's
correct.
correct.
That's actually how we met. We both met as interns at the Fremont factory, um, working together in industrial engineering, actually, working on improving the assembly lines for Model S and Model X. And
Ooh.
then we got our hands a little bit wet with uh, automation for Model 3 at the time.
And so what years were these around?
2017,
2017.
it was like
Okay.
almost the whole year of 2017.
So that's
Yeah.
like start of the Model 3 production and ramping up.
Yeah,
So that was
Yeah.
the production hell phase.
the
Yeah, it
production
was
hell
it
phase,
was right at the
exactly.
beginning of that. That's right.
We were actually in the crowd when that term was first coined, production
Wow.
hell. We were right there in the crowd. Yeah.
Wow, that's really exciting. And so, could you kind of talk us through both of your experiences at Tesla and now being at the helm of the startup? I'm really kind of curious about the path in which you guys took to get here.
Sure, I can talk about that a little bit, and I'm sure Shashank can expand on it because a lot of it has to do with us meeting. And before I ended up working at Tesla, I had started a senior project for my mechanical engineering schooling. And what's really neat about the program at San Diego State is that at the time, at least, you got to choose what you wanted to work on. And I was really passionate about regenerative suspension. And so that's what I started the project with. And interestingly enough, a couple months in fact, going through the entire semester, um, there it's broken up into two parts. You have part A, which is the first semester, and then part B, which is the second semester, and you've got to complete the entire year to say that you've finished your senior design. I had completed the first half of the design and actually got an A. And the opportunity to be an intern at Tesla came about during that time. And I went to the president of engineering and told him that I'd really like to take this internship and it would require me to take some time off from school, or I can continue the project remotely, right? This was pre-COVID days. Doing anything remote was just unheard of, pretty
Hmm.
much, um, and denied my request. So I decided at that point, you know what? This is kind of a once in a lifetime opportunity for me to take this internship at Tesla and forego my senior year of engineering and have to redo my entire senior project. So
Wow.
the project that actually got me started with this um, passion for electrification um, is what actually got me to have to redo the entire year of my senior year at school. So went to Fremont. And by the way, before I got my internship, I was actually working part time at Tesla in sales locally to San Diego. So I was doing a lot of work in educating the general public. As you might know, Andrew, Tesla doesn't have a dealership style uh, type of sales platform. They're really based on educating people by using malls. And
Hmm.
that's exactly where I worked, was at a Tesla store or showroom at a couple of the different malls in San Diego. And also I had a hand in delivery as well. So once customers purchased their vehicles, I was also the person assisting them in getting their new Tesla, which was really exciting too. And so um, I then took the internship, or had the opportunity to take an internship in Fremont, and um, had to forego my senior year of mechanical engineering. And I thought, well, um, I can always come back and finish that year if I have to. And so that's exactly what I did. I went to Fremont and met Shashank there. And we shared a little bit about the projects that we both had been working on in school, which he had some ideas for energy harvesting that he had worked on at school as well. And so we kind of connected on that. And the rest is history. Um, you know, we did have to go our separate ways as far as work is concerned. Shashank went on to pursue his master's degree, and I had to move back to San Diego for personal reasons, and ended up um, finishing school at SDSU, taking a whole nother year, and getting a job with the Navy as a mechanical engineer working on UAVs. So during that time, I've also um, officially started Ganaio and incorporated it, and just worked on it on the side um, while I had my day job. Um, so yeah, and that's kind of where we are today. We applied for a patent, um, of course, during Shashank's time away from Tesla, so that there wasn't a conflict of interest, and we were granted the patent for our regenerative damper in February of 2020. And we've been communicating with automakers ever since, and investors, and that's kind of the point that we're at today. Um, and, we've also got a product that's uh, yet to be released. Actually, December 10th, we're taking a little bit of a company pivot in offering a physical product for the everyday consumer. And what's really cool about this product is that it still falls under the umbrella of extending the range of your electric vehicle, which is what Ganaio is all about, and allows people to be able to install this um, very easily onto their car and instantly gain anywhere from 7 to 10% of range. Um, so we're not going to talk a whole lot about that because we haven't revealed it just yet, but that's kind of what we're so busy working with right now, and getting that product dropped on December 10th. So, yep.
Cool. So I think one of the biggest questions I have is, this is just kind of one high level thing, and I was running some very basic calculations on this, but the claim of 2000 watts is, that's a lot of energy, or sorry, that's a lot of power, especially continuous. So can you kind of talk me through this first claim? Because lots of power. Is this based on vehicle, based on types of road you're driving on? I would assume if you're driving on a city road that might be more bumpy, there's obviously going to be a lot more suspension travel in there. Probably stop and go traffic, there's going to be a lot more compression in the suspension. But I ran just a brief calculation. It showed like a 2,000 kilogram car could, yeah, very likely produce 2,000 watts instantaneous power, depending on road surface, and obviously lots of other stuff, how long it takes for the suspension. But yeah, can you just kind of walk me through that?
Yeah, so everything starts from Faraday's law of induction. And basically, if you remember from science lab in high school, using a galvanometer to see voltage kind of jump up or jump down whenever you pass a cylindrical magnet um,
around the
against
coil.
a copper coil.
Yeah.
And that's basically how it works. And in fact, when we first did a patent search for what we came up with, we were shocked that this hadn't already been patented. Like, it's actually like Faraday's law with a small modification. And what that is basically the cylindrical magnet that I'm talking about in science class that goes inside of the coil is what Faraday's law is based on. But what we've done and tweaked about that in our patent is a ring magnet that's situated around the coil, which moves in sync with the inner magnet.
Hmm.
And so that's how we're able to increase the magnetic field, which, going back to Faraday's law, you have the number of coils multiplied by the magnetic field multiplied by the cross section of that magnetic field, all divided by time, equals your induced voltage. So when you increase the magnetic field, you're going to increase that voltage. And depending on your electrical output setup, because when it comes to electricity, V equals IR, right? So voltage
Mhm.
equals current times resistance. And you can manipulate that with resistance, um, and not so much the current, because the current is going to be within the design um, of the thickness of the coil
Of the
itself.
coil.
And so you have some limitations there, but at the end of the day, when you increase your magnetic field and the cross section, which is the diameter of that coil with the diameters of the magnets, you can't lengthen them. It's not going to do anything for you as far as the magnetic field is concerned, but
Yeah.
you can make them radially larger and increase that magnetic field. And so another uh, big factor in um, giving you a higher induced voltage is actually time. And what people don't realize is when your suspension drives over a bump on the road, which, by the way, on average is 20 millimeters up and down for every meter you drive forward. Um,
Yeah.
that's going
Wow.
to uh, cause your suspension to travel at about half a second or less,
Yeah. And
depending
the
on
quicker it
how
is.
fast you're driving. And
Okay,
that's
yeah, because
yeah,
when I was first running these calculations, I had no idea how long it takes versus because I mean there's so
Yeah.
many factors. So can we
Yes.
just say that one more time? So that's for every 1 meter you drive, there's 20 centimeters of
20,
20,
compression.
20
millimeters.
millimeters.
20 millimeter. Okay, yes,
20
20
millimeters of
That's about
millimeters.
this
displacement.
big. Yeah.
So okay,
And this
I'm gonna write
is
that down.
and this is at highway speeds of about 60 miles per hour.
And so
And
this is on highway.
regular, yes,
Right.
This is
regular,
not driving through city.
That's
So
right.
this
no.
is
Yeah.
just
Yeah.
constant speed, highway. And we would
Mhm.
assume that this would probably be a scenario in which there is the least amount of suspension travel if you're just driving straight down a highway at like 60 miles per hour. Because
So,
I
so
would
there, yeah,
definitely, yeah, you can go
that's the
ahead.
caveat. You know, when you're on
Yeah.
the freeway, you're not going to have as big of bumps, but
Mhm.
those bumps are going to be coming at you faster.
A lot of
And so,
frequency.
right. But on city streets, it kind of levels out, because
Hmm.
although the suspension is not going to travel as fast, the bumps are going to be bigger on
Bigger.
average.
Mhm.
That's pretty cool. Interesting. And then I would assume, so, okay, yeah, I mean, we can go into like all the specificities here, but like even like if you're driving on a dirt road or something like that, maybe you're driving like really fast on, or not even really fast, but obviously like the type of road you're driving on is also probably going to have a pretty big effect on suspension travel as well. So if you're going to be driving on, um, I don't know, you're going to be driving on some dirt road out
Yeah,
in
Right.
uh, on your way out to Joshua Tree. It's probably
sure.
going to be a lot more suspension travel there than if you're just on
Mhm.
the highway going down.
Right. And when
Yeah.
we give that claim of 2000 watts, it's considered a real average. Um, we haven't been able to show much more than that in our lab setup, because we just don't have the resources to do that just yet. Our lab setup actually is able to show us speeds only up to about 20 miles per hour. So if
Hmm.
you can just imagine, we've got these parts moving really fast inside of my garage at home. We don't actually
Yeah.
have a facility for this. And so
And,
we also try to do this on an electric bike, which we actually proved to be able to increase the electric bike's range using our
Really?
regenerative damper. Yeah. And
And is
that's
this
part
a
of,
bike with the? Is it just a bike with front suspension, or is it rear suspension as well?
yep, both. So you've got the
Okay.
front fork suspension as well as the rear damper. But by putting our regenerative damper in conjunction with the front fork, we were able to put two of them in series. And so what that does is just uh, multiplies the voltage by two, which also gives you double the power. In a bike, of course, though, it's much less for a couple of reasons. For one, you're traveling at much smaller speeds than you
Smaller
would be in a
speeds.
car. But also, the bumps at which you're going to be hitting depend on how you test. So this is a
Mhm.
fun story to tell. When Shashank and I first were working on developing the damper for the electric bike, we took it to these really bumpy bike trails near where I live. And as far as our what our calculations were telling us, we needed to ride the bike anywhere from 15 to 20 miles per hour to be able to increase the bike's range by about 7%. Okay. So I'm like thinking, great. Like, yeah, bikes go 15 miles per hour. I can at the very least do that. Well, it turns out that when you go over bumps at 15 miles per hour, and I'm talking like anywhere from like 6 to 12 inches of a bump, which is about 5 to 10 times more than 20 millimeters, you uh, you're going to be scared for your life.
Mhm.
And so we actually couldn't test it because we were just too afraid to be able to continue that. So anything past 20 miles per hour, which is what we were able to prove on our lab setup, is interpolated. And so what you'll find at 60 miles per hour is our interpolation of 2000 watts.
Interesting. All right. So when it comes to ride quality, how will this affect the overall just feel of the vehicle on the road? Will this contribute to maybe a stiffer ride, or do you expect no change at all?
Do you want to take that first, Shashank?
Yeah. So there are two configurations that we could have with the regenerative damper. The first one is a plug and play approach. And with that, there would not be any seeming difference in the ride quality of the vehicle because this would basically just add on to the existing suspension system. So if you already have a stiff suspension, that's what you're going to be left with. If you have a super smooth suspension, then that's what we're going to be left with. And this is just going to harness power from the displacement. And the second configuration is where we are still doing a lot of work in terms of how we can incorporate different suspension techniques that are already existing. One of which is an air suspension, which would basically have its own way to adjust your ride and comfort quality based on the amount of air you would have in the air suspension that is integrated with the regenerative damper. So yeah,
Interesting.
it's still a pick and choose based on your preference.
Yeah, just to
Okay.
expand on that a little bit, from the scientific approach, it's all about matching the forces that you're going to expect from the particular vehicle that the existing dampers are designed for. So
Mhm.
Mhm.
if you're going to be designing for, let's say, an off-road truck, yeah, you better make sure those dampers can handle the type of forces that that type of vehicle is going to see. But the advantage there is that you're going to be able to have more forces to pull regenerative wasted energy from, and be able to use that. And what that is basically, um, every damper is going to be inefficient. It's not going to transfer energy anywhere because it's not meant to do that. What it's meant to do is just to um, combat the forces that it's working against as the vehicle is driving along. And what that turns into is heat dissipation. So
Hmm.
that's where all that energy is going. It's going into the atmosphere. And so what we're doing is, instead of having that energy dissipate as heat, is to capture it um, magnetically and electronically transfer that energy to the battery pack.
Interesting. Now, when you say plug and play, what is the process of getting the energy from the damper into the battery pack? Will this go to high voltage? And what was the process look like from that?
Yeah, so when we say plug and play, I think it has more of a meaning of that it's going to be something that can be replacing the damper at the factory so that there
Mhm.
doesn't need to be any kind of change in the assembly line. But also in the sense that because it's going to be connected to the car electronically, um, excuse me, electrically, um, then you're going to need to match the requirements of that vehicle. And one of them is the voltage of the battery pack.
Yes.
So, one great example is off the top of my head, I don't remember what it is for Model 3, but for uh, uh, I think for no, maybe it is for Model 3, a 320 volt battery pack. And so if the battery pack is at 320 volts, we need to be able to match that voltage at the very
Yes.
least to be able
Mhm.
to charge it at all. And
Yeah.
there is something in between the two that there's something that needs to happen in between the two. And what that is basically the communication of that energy coming to the battery pack, which is through the battery management system.
Mhm. And
Um,
is the energy going to be in AC, or is the power going to be in AC or DC coming from the damper?
Directly from the road, the damper
Mhm.
is going to be alternating current.
Okay.
Because you're
So I would
switching
assume,
switching the directions, right? Because your
Mhm.
yeah,
suspension's not just traveling in a singular
yeah,
direction.
going up
It
and down.
goes up, comes down. So that's an alternating motion, and the power you get is also alternating current, and then you have to rectify it into DC.
Yes. So then would that go through like the so would this be basically be treated as a AC charging session? So it could then go through the onboard charger in the vehicle, then the voltage will be boosted to meet the battery pack, etc. Is that kind of the route that you think it would take?
You're on the right track. So as far as battery management systems are concerned, they're going to receive direct current and
Mhm.
transfer that direct current to the battery packs as needed. And
Yes.
so what we need to do is be able to supply our our power as direct current. And what that means
Mhm.
is that we need to come up with an electronic suite of parts
Mhm.
that's going um, to do that. And so, as Shashank just touched on, we've actually designed our own circuit. You know,
Mhm.
being mechanical engineers, um, you know, electronics are not our sweet spot, but we did figure it out. And basically, you have the alternating current, which is going to be supplying you, depending on your design for the coil, a high voltage with low current, but still be
Mhm.
able to get the power you're trying to get out of it. And so, what you need to do is to lower the voltage and bring the current up. And you can
Yeah.
do that by using a transformer. There
Mhm.
are some inefficiencies there, though, and I'll touch on that in just a second. But you also need to add in a rectifier, which is actually going to convert the alternating current to direct current. So you've got the transformer,
Mhm.
you've got the rectifier, and now you need a specialized series of capacitors, which are going to level out the voltage enough for the battery management system to receive. And so, going back to the efficiency of all of these systems combined is about 85% because we're losing 15% of the power that's being directly pumped from the regenerative um, core design and past the electronics.
Wow. Interesting. So, yeah, because that makes me think. Because I mean, just looking back at when I did some work on the AC chargers at Lucid, is you can kind of watch the power flow on these dashboards of like
Mhm.
AC. So it'd be like 240 volts, 40 amps, and then it would have to go through the onboard charger. The voltage would get boosted, and then the current would obviously go down just to make sure the power. I mean, because obviously there's going to be efficiency losses there, so the power is going to lessen. But yeah, basically you're just going to boost the voltage and lower the current going in. So that's just pretty cool how this is all going to work. And I would assume because every EV is going to have different battery voltages, even cars that are
Voltage
both
requirements.
400 volts.
Yeah.
Like a Model 3 is going to have
Mhm.
a different battery voltage than a Chevy Volt or something like that. And then, so it's super fascinating.
We know how much power we can generate. It's a matter of what does that power look like in terms of voltage or current, because that can all be manipulated with electronics.
Yeah. And then, like you rightly stated, the break-in voltages are going to be different across different manufacturers, and that's why this particular product is a B2B, as in it needs to be at the manufacturer level and not directly at the customer level, because it requires integration of electronics based on that particular car's electronics and electrical infrastructure.
Yeah, I guess unless you're like a rich rebuilds type, I don't think that anyone could really be able to do that in their own garage. But yeah, no, that's really fascinating. And yeah, I'm now I would even assume that, because like for hybrids too, because this could also be applied to hybrids. Obviously, hybrids different battery voltages as well. But what type of efficiency gains are we seeing specifically for EVs in here? Like how much, what percent increase in efficiency? Just if we just say a generic EV, obviously I would assume it'd be different for lots of vehicles, but do we have general numbers on that?
Yeah, so it all starts with just how inefficient dampers are, and what that looks like as far as numbers are concerned is and we're talking like on average, and it definitely depends on the existing efficiency of an electric vehicle, generally speaking. But we found that on a vehicle, actually, like the Lucid Air, is wasting up to 17 kilowatt hours of energy in heat dissipation just through the suspension, the dampers themselves. And so, being that uh, we believe we can capture 85% of that, we're able to restore about um, 13 kilowatt hours, 14 kilowatt hours, which in the grand scheme of things is about 12% increase in driving range for the Lucid Air.
Wow. Because even if you assume the Lucid Air gets 5 miles per kilowatt hour, which is a little generous, I mean, that's pretty impressive, because you're looking at like 65 extra miles of range on a full charge, which is pretty significant stuff. Wow.
Yeah, exactly. And like I said, it really does depend on the efficiency of the existing vehicle. And as you know, Lucid makes very efficient vehicles. In fact, it's argued that Lucid makes more efficient vehicles than Tesla does. And it really comes down to a plethora of things, including aerodynamics, the suspension system, the drivetrain, how well the HVAC system, or how efficiently the HVAC system works. And so all of those things summed up only makes our system better, because it's going to allow the vehicle to drive further, allowing our suspension damper to capture more energy as you're driving further. So yeah, on a Lucid Air, we're estimating that we can increase its range by about up to 12%.
Wow. And this, because when we look at this, I'm just trying to think of this just on the vehicle alone. So some of the biggest factors I would assume is going to be weight of the car to get more. I mean, obviously you get a heavier car, then it's going to be less efficient.
Then
so
it's
I guess
also going
maybe
to be
it's
less
like
efficient, exactly.
So it's kind of like a non-zero sum game. So it's not like okay. Yeah, so I would assume that probably it would be roughly proportional if you're in like a Hummer EV. I mean, just if we ignore aerodynamics, maybe like a 9,000-pound Hummer EV versus, I don't know, a 3,000-pound Mini Cooper SE, because there's just going to be less force.
Right. There are going to be three main factors. The first is weight, just like you said. The second is what is the estimated range for that vehicle from the manufacturer. And then the third is what is the size of the battery pack. That's going to tell
those are
you
both
how
efficiency.
efficient. Yeah.
Okay. So basically efficiency and weight are very key. But yeah, because this is really interesting too, because even in I mean, because I could see this being applied in different applications as well, besides passenger vehicles, even like buses or trucks or something like that, which are now becoming electrified, because right there you have something that you're probably losing a lot of energy just to suspension, just because it's such a heavy vehicle.
Right. Right. Yeah, but then at the in the same token, a bus is just not going to be as efficient with the energy that it's using because it is so heavy. But
Yeah.
because it is so heavy, we're actually able to get a faster deflection in the suspension, which is going to induce a higher voltage, giving you more power. So
But
yeah, there's definitely
it's basically when you average out everything, considered all the factors that we spoke about, it's going to be a fraction closer to the 10% number of what range it already achieves. If it's a vehicle that's currently achieving 100 miles, then you say you're going to put the extended range around 110. But if it's a super efficient light vehicle that's achieving upwards of 400 miles an hour, then you're adding 40. But 40 is the same 10% as 10 miles is to 100 miles. So that's basically how it balances out based on the existing efficiencies of that vehicle.
Wow, fascinating. And so now with the product, so you're kind of focusing more on a B2B side. Do you have any estimated timeline? Because you mentioned there's a launch December 10th, I think you mentioned. And so what do you think the timeline is for the near future with getting this new damper into production?
So the damper, with the damper, we've spoken to multiple automakers about which we've received a resounding yes on, hey, let's integrate this in our vehicles and work with you guys on starting pilot programs. The problem is that they would really like us to be at a very specific product development stage, which we probably need somewhere around $1 million of funding to get that going, and we're just not there. So we thought to ourselves, well, if the automakers are willing to work on this with us at a specific um, development stage, then maybe investors would be interested in helping us getting to that point. And so when we reached out to investors, all we could hear is them wanting to see what our revenue looks like, which is zero. So we went back to the drawing board and we're like, well, what are we going to do? Because obviously we have something here and the automakers are very interested, but we just don't have enough money to get to where we need to get to be able to start these pilot programs. So we thought, hey, maybe we can come up with a direct to consumer product, something that we can sell and generate our own revenue with, and not just be able to potentially be able to fund the product development for the regenerative damper, but also to be able to prove to investors that we are an investable company and that part of their investment can go not only towards the direct to consumer product, but also towards the regenerative damper in the B2B um, layout. So that's where we're at now. And, we're trying to hype up our direct to consumer product as much as possible up to the reveal date. And it's going to be something like you've never seen before. Well, it'll be similar to what you've seen before, but it's definitely not what you see today. I'll just leave it at that. And so what we're hoping to do is to be able to garner as much interest before and after we reveal it and just see where it goes. If we get sales, then not only will we maybe continue in that pivot to creating products for direct to consumer, but also feed our regenerative damper in the B2B layout as well.
And do you have a proof of concept like in a vehicle right now? Because I think like what will be really interesting just in my head is like, hey, you have a Model 3 without just stock one, and then you have another one with the regenerative dampers in there. And I think it would be like really cool if it could be like a range test between both of them just to just for
With the
people to
regenerative
see.
damper, you mean?
Yes.
Yeah.
So one with and then one without.
believe it or not, it is very difficult to even get something on a car, and that's basically what we would need $1 million for. Um,
Wow.
there's so much that goes into designing dampers to be able to be roadworthy, because what we've got in our lab setup is not acting much as a damper, but more as a regenerative device in itself. Really, just translating the um, voltages and currents into power on a benchtop. And you don't need a lot of the same requirements that you need for an actual damper that's going on a vehicle. And so that's where we're going to need a lot of help in developing it.
And when you mean requirements, you mean maybe by the National Highway Board, or?
Well,
Just the automakers themselves, like just getting
Okay.
an understanding of their existing architecture, their existing BMS systems, and how a regenerative device or suspension can replace or go along with their existing suspensions. So, as we mentioned earlier, each vehicle would have its own set of requirements or parameters that we have to account for, right? So, the pilot programs that John was mentioning about would be our final step towards roadworthiness and having the kind of side-by-side comparisons for a testing standpoint, like you just mentioned. But however, for the D2C product, though, we do have a road-ready version prototyped, which can be used for a side-by-side comparison of a vehicle with and without the particular product that we're talking about.
Interesting. Okay, that's pretty cool. So more so the path is getting enough funding, and then where are these manufactured right now? Are these made by hand, or how does it
yeah.
work? I'm curious.
Out of
So
John's garage.
yeah. So right now, we've built and designed the manufacturing intent for this new product. And so once we can prove that there is a demand, which are going to allow for a month or two of pre-orders to prove that out, then we're going to be able to start manufacturing right away. That's also what's so innovative about this new product is the manufacturing that goes into it itself, which we'll be able to talk more about after we reveal the product. Um, but also, what's been so neat about this product is that it's actually very simple in nature as compared to our regenerative damper, and so it hasn't required a whole lot of finances out of us. You know, although we're bootstrapped, we've only had to spend about $6,000 on getting this set up
Wow.
and being able to test the market. Whereas testing the market with the regenerative damper is what would cost the about. I mean, it could really range. It really depends on the automaker, just like Shashank talked about. But I would say at a very minimum is about $500,000. And if we felt comfortable starting out in developing the regenerative damper, then that's why I bring up the $1 million. But yeah, as compared to the $6,000 that we spent on our new D2C product, it's actually a little bit scary, I think, for people in this new industry. I'm sorry, I'm talking so vaguely, but um, we'll get to find out in exactly 2 weeks what that is, and we're really proud of the work that we've done on it, and it's going to be different, but hopefully cool enough for people to want.
Yeah. I think just to while still keeping it vague for that final moment of when we reveal it. I think the gist of it is if you're a customer that drives an electric vehicle, you're able to just purchase this D2C product. John, do you want to tell them what we're going to call it?
Yeah, I mean, it's posted on our website. We're calling it the Ganaio Shield,
Yeah.
and I won't say exactly what it does, but basically, it's a physical product that anybody can just buy from us.
Yeah, you can
And
buy it, put it on your car, and then you're getting 200 miles of range on your vehicle right now. You put this on, and uh, the next day you start driving. and you can expect about 220 miles of range from it. Let us just put it that way. So this is our damper.
Interesting.
I think you already know about it, but
Yep.
the shield that we're talking about has nothing to do with the damper. You're just going to pick it up, put it on your car. It's going to be a very quick installation process, and then you will basically end up achieving more range.
That makes me wonder. I'm not really sure what direction this is going in because it is very vague. But I guess I'll have to wait until December 10th to figure it out.
Just check the website on December 10th, and you're going to find out what it is. And then
All right.
you'll probably ask yourself why it was, so difficult to guess. And then you would also go back and say, actually, it was difficult to guess. So, yeah.
Yeah, here's the thing, and here's a little bit of a hint, right? There are multiple ways to increase the efficiency of any type of vehicle. And just like you would increase the efficiency of a gas powered car, even with something like our own regenerative damper, because that can easily be applied to something like the 12-volt system of a
Yep.
vehicle, and increase the miles per gallon. And in the same way, it would also work that way with our new direct to consumer products. This can actually be used for a gas powered vehicle as well, technically. In fact, I'll let this out. This has been used for gas powered vehicles in very early history of cars. And I'll just leave it at that.
Okay, I think you gave too much away, John. He's going to figure it out in a couple days.
I'll do some research and I'll get back to you. Okay, that sounds really fascinating. I think everyone's on some sort of level of suspense right now because we're very curious. I'm very curious where this is going to go. But I think, yeah, just in the grand scheme of things, I think it's really interesting that this hasn't been implemented already, just this technology, because it seems like a very logical step with just the force of suspension. It's kind of interesting that that's not been put in place before. But I think now, especially when you have this patented, I think that is really cool. And I can imagine cars like Lucid, where efficiency is basically the number one goal of the vehicles. And if you could be able to get like 10 to 13% more range with that, that could be a game changer for a car that's already insanely efficient.
Yeah, definitely. And you must be familiar with Aptera, where they're
Yes.
claiming up to
And they're also
1,000
based
miles
right
of
near
range.
you.
They're
Yeah.
based right here in San Diego. And what's really neat about them is that their whole goal is efficiency, obviously. I mean, just from the way that their vehicle looks. And so, we've actually spoken to them as well about our regenerative damper. And same kind of thing is that they would like for us to be at a certain development stage with our damper for them to be able to start a pilot program. But what would be absolutely mind-boggling is that their claim with 1,000-mile Aptera would take on something like our regenerative damper and increase the range even further than 1,000 miles at maybe 10 to 12%, like we talked about earlier, more.
Yeah, that'd be pretty crazy. But yeah, so I think that's a big thing, just because this could be applied in any automaker's vehicle from the factory, and the fact that you can get significantly more range through something that's just otherwise wasted energy. It's because it's kind of like thinking about a EV that can't do regen braking. It's like, why not? It's like,
Right.
you have this opportunity, collect that energy.
And I do want to address one thing you had mentioned in that, this hasn't been done before. And it's not that it hasn't been done before, because automakers have actually tried to design regenerative dampers, as you'll see with BMW and Audi, very publicly. Actually, you can find their patents on it. But what you'll find, in fact,
it's
we've
just
actually
a method.
spoken to BMW directly about their design, and they're like, "Yeah, yours is much more efficient than the way that we've designed it." And the reason for that is because they're using designs that involve clutches and flywheels in their damper.
And
So
gears. So
you
they're trying to convert energy.
right.
So basically, your suspension's moving in a linear motion, right? What they're
Mhm.
trying to do is convert that into circular motion through a series of flywheels and gears, and then convert that motion into power. So you already know that any kind of mechanical system is going to have inherent inefficiencies, right? Like depending upon your gear transfer ratio, your clutch transfer ratios, or what kind of flywheel you're
Friction.
going to use, you are going to lose a portion of the power that you would have otherwise collected just to the translation from one type of motion to another. That's what we
Wow.
basically circumvent with our system, because here the generation of power happens directly through linear motion and there's no conversion to another type of motion.
So they've been able to produce up to 10% efficiency,
Hmm.
whereas we've been able to produce 85% of the energy that comes into a
Wow.
damper. So of the 17 kilowatt hours in a lucid air, they are only able to capture 1.7,
Hmm.
whereas we're able to capture about 13. Um,
Was
Now
that only in concepts? Has like BMW put that into production vehicles or?
they have not put it into a production vehicle.
Okay.
So and that's where you would be right, in that this
Mhm.
has not been done in a production vehicle,
Yep.
but it definitely has been made as a prototype by BMW and Audi, very similarly in design, using the clutches, flywheels, and gears. Now, I also have to say, not only is our design better because we're able to achieve higher efficiency with the damper in collecting energy, but also it's easier to manufacture. So
Mhm. Yeah, because I
I
would
don't know.
assume clutches, flywheels is probably not really easy
Yeah.
to
Exactly
mass
right.
manufacture.
So we have a proprietary design in the way that the magnets interact with the coil in sliding up and down past the coil. But that's basically what it comes down to, is that you just need them to move past each other. Um, and what makes our design even more unique is that the internal magnet that's situated inside of the coil is not held by any physical part. It's held by the magnetic force of the
Mhm.
external ring magnet. And so it moves along the um, axis um, inside of the coil um, by the force of the outer ring magnet, requiring no mechanical parts to push or pull it. So
Wow.
Yeah.
that's even more reason to it being easier to manufacture and cheaper to manufacture. So these are kind of the two reasons why this hasn't been put into a production car yet. And we believe that we have the key to that. And that's going to come down to the simplicity of the design, and the
Mhm.
simplicity of the manufacturing.
And do you think a reason why this maybe hasn't been implemented before is just because it would be considering probably in the past these maybe have been experimented on maybe gas cars for the 12-volt system? Do you think this is something that hasn't been maybe implemented as much just because there's been more focus on gas R&D on the past for the history of the
Yeah.
automobile besides really early days? And do you think that's kind of maybe this EV spike is kind of what's getting more people interested in it now?
Absolutely. I think with the advent of electric vehicles, you have new types of technologies coming out. If you just look at the Model S, the original Model S that came out in 2012, Tesla had to design their own in-house electric motor. And they couldn't just use something from, let's say, a go-kart or a golf cart, right?
Mhm.
Because or a forklift, because those types of motors aren't going to be able to propel your vehicle the way that you would need it to, efficiently, but also conveniently for someone who's trying to get up to highway speeds when they're traveling. And so they had to come up with a uh, proprietary motor, which, by the way, Tesla's very open about their patents, and have even opened up this patent for other automakers to copy without any regress. And so, that's just kind of more proof to how new technologies need to be made for the advent of electric vehicles to succeed. And this is one of them.
Wow. Yeah,
And I also
I'm very
think, and I also think a lot of subsystems, auxiliary systems for vehicles have technically just remained the same and crossed over from, say, your gas-powered vehicles to the electric vehicles. And then once the traction for electric vehicles started taking off is when more innovation started happening in the auxiliary space as well. Right? Like, for example, you can talk about the 12-volt system that was basically standard for any automobile before is now transcended into 48-volt systems that companies like Tesla and maybe a couple more are trying to bring in with their flagship models, right? So I think the focus initially was on just making sure that the traction for electric vehicles was there. And then once those volumes started picking up and then people started taking electric vehicles seriously is when the focus has actually now started to go towards all the other subsystems and auxiliary systems from an efficiency standpoint, if that makes sense. So I think there's a lot of other cool innovations that are going to come in the near future as EVs take off and become a mainstream and primary automobile driver. And then I guess we're going to see, if not just suspension, people are going to start getting more brainy about how air conditioning works. Like, for example, there used to be just heating through coils before, and now Tesla introduced a heat pump. So I think subsystems are going to evolve in particular towards electric vehicles in the near future. So we are a step in the same direction.
There is a lot of focus on battery technology development, which is really great. But I think a problem that people don't realize, and Andrew, you might know this when it comes to the energy density. When you compare batteries to gasoline, you're
yes.
talking about only
Gas has 1
50%.
gallon has 33.7 kilowatt hours.
There you go.
So,
exactly.
yeah.
And that's kind of why manufacturers are forced to jam in up to 40% of a vehicle's total weight in just batteries. And then, more than that, you have the cost of batteries, which is much more than gasoline. But where the difference comes in and why electric vehicles are becoming popular is because of these efficient systems that are utilizing these batteries more efficiently. And that's evident in the statistic that you'll find that electric vehicles use up to 85%, or at least 85% of the energy that's supplied in electricity from their batteries. Whereas a gasoline vehicle, although has a much higher energy density, is only
Very
using
inefficient.
17%.
Yeah.
To be able to get the car to go forward.
Mhm.
So yeah, I mean that's really what the advent of the electric vehicle is, and how these subsystems are able to um, utilize batteries more efficiently. And I think that combined with uh, more battery developments in technology, we're going to see electric vehicles with more range than a gas vehicle is able to provide.
Yeah, this is very exciting times, and I think this technology is really going to be key to capturing that energy that's lost and using it to help you go further on a single charge. So I think whenever there's a chance to test out a car with the suspension and concept, let me know, because I think that will be
Sure.
very awesome. And I'm
Absolutely.
really looking forward to seeing the launch on December 10th. I'm still curious about what exactly this is going to be. But yeah, very excited regardless.
I think you can be part of testing the Shield sooner than you think. Maybe in a month and a half from now.
Yeah. Yeah,
I have a Model 3. I'll be interested.
there you go. Yeah, with Shield, we're much further in development than the regenerative damper.
Yeah.
Are you familiar with the technology readiness level chart?
Yeah, TRL.
Yeah, TRL,
Yeah.
exactly. So we kind of define ourselves, and I think it's something out of 9 levels. We're probably somewhere around a 4 with the regenerative
Okay.
damper. And I would say that with Shield, our direct to consumer product, we're probably at an 8 right now.
Wow.
And so once we can secure demand, once we reveal it on December 10th, we're going to set up level 9 actually very easily, and be able to start cranking these out within a month or two.
Wow. That's very exciting and still very suspenseful about what this is.
So sorry.
Yeah, I will be on the lookout.
Make sure you follow us. Make sure you follow us on Instagram and LinkedIn to stay up to date for the updates.
John
and
put
when
me
it
on
launches,
the newsletter.
You'll be one of the first ones to find out.
All right, sounds good. And yeah, thank you again, John and Shashank. Thank you so much for joining the podcast today. I learned a lot from you both.
Yeah, thank you for having us.
Thank you so much.